Okay, this is page 5 of the lines unit. We're going to start out by talking about two special kinds of lines, which are the horizontal and vertical line, as opposed to the mostly diagonal lines that appear in a majority of problems when we're talking about lines in math class. Okay? In one way, horizontal and vertical lines have much easier equations than diagonal lines, and in one way, they're kind of tricky. So let's talk about it, okay? Like we talked about a couple pages ago, if we were going to identify the coordinates for any of the points on a horizontal line, we would see a pattern in that the second coordinate, the y coordinate, of every point on this line is the same. It's a 2. Okay, and it turns out that the equation for a horizontal line is y equals 2, because basically what that says is x is anything, because we don't even say what x is, and then we say that y always has to be 2. So that is the definition of horizontal line. A little bit tricky because horizontal lines are parallel to the x-axis, but the variable that appears in the equation is y. Okay, let's move on to vertical line. In a vertical line, if we write the points that are on the vertical line, so this is really useful to easy to do on a graph if you have a graph. So if you are thinking about horizontal and vertical lines, it helps to draw a picture and to label some points. So I have 3, 6, I have 3, 2, and I have 3, 0 here. You see that the first coordinate is always 3, the x coordinate is always 3, so that means that the equation for a vertical line always starts with x equals and then 3. Okay? And whenever they ask you for the equation of a vertical or horizontal line, you must start out with x equals or y equals, and you cannot just write 3, because what is 3 equal to? Is it equal to x or y? So you need to say x equals 3 or y equals 3 so that you know whether it's a horizontal or vertical line. Again, vertical lines, a little bit tricky because they're parallel to the vertical axis, the y-axis, but the variable that appears in the equation is x instead of y. Okay? All right. Let's go back and review gradient intercept form. The only thing new about it here is we used to call it slope intercept form up to 10th grade. Now in IB, we're going to call it gradient intercept form. Gradient, it just means slope for us, okay? So basically gradient intercept form is the most commonly used form of the line in our class, and it shows totally obviously the gradient value and the y-intercept value. Okay, and how does it show it? Well, first of all, you're always going to have x and y in an equation. Don't try to fill in the x and y with a number, because then it won't be the equation of a line anymore. Okay, and then the m value is the slope, okay, or the gradient, and the k value here, usually I think in the formula sheet it's let's see, oh, here's the formula sheet excerpt. You can see that in the formula sheet it's called C. Here they decided to call it K just to be even more confusing, right? So this is the y-intercept. All right? Always be careful when someone asks you for the slope, look to see what's multiplied times the x, but don't give the x as part of the slope, because the x is not part of the slope, just the number being multiplied times the x is. Okay? All right, let's do some problems now. So the next problem says, find in gradient intercept form the equation of the line. And so it says with gradient 3 and y-intercept 0, -2. This is pretty easy because, remember, gradient intercept form has y equals mx plus c, where m is the slope or gradient and c is the y-intercept. So let's just replace the m value with 3, because that's the gradient, and we'll replace the c value with -2, okay? If the y-intercept is 0, -2, that means it's this point here. The 0 is just indicating that the x value of the y-intercept is 0, which is obvious because the y-intercept, the definition of the y-intercept is the part of the line where x equals 0. So this doesn't really give us any additional information. We're interested in the -2. Okay, so we're going to put the -2 in for C. If you want to, you could write -2, right? So that's part A. Part B says, give in gradient intercept form the equation of a line with gradient -4 and passing through -1, 5. Ooh, that's pretty tricky because they're giving us information which doesn't give us the y-intercept directly. So let's use a picture to help us do that. And we're going to learn a different way to do it in a couple pages. But for now, let's just do it with a graph, shall we? So we're gonna graph -1, 5, which is this point here. And then we're going to draw the gradient -4 here. And the gradient -4 means rise -4 and run 1. So that means it's going to run to the right by 1 and it's going to go down 4. So that means it would go 1, 2, 3, 4. It would go through this point here, right? So basically it would go through these 2 red points, kind of like that. Okay? And so now we can write the equation of the line in gradient intercept form because we know the y-intercept of this line, which is 0, 1. So we could write down that for this line, which has a gradient of -4 and passes through -1, 5, it actually has a y-intercept of +1. So we could write -4x + 1. Okay, so it doesn't give us the correct information to directly write the gradient intercept form, but it gives us enough so that we could start drawing a graph, and from that we could write it in gradient intercept form because we can easily see the y-intercept then. Okay, so that's one way you could do it. C, passing through -1, 1 and to -3. So again, they didn't give us the y-intercept and they didn't give us the slope either. Okay, so one way you could do it is you could graph, okay, -1, -1 and to -3. We could do it like that, right? We could say, oh, this line actually, the y-intercept is -2. And the slope appears to be, let's see, it goes down 2 and goes over 2. So that would be -2 divided by 2, which would be -1. Okay? Now, why am I not writing this down? Because the easiest way to do this, remember, they think they're being really difficult because basically what they're doing is they're asking you for the equation of a line that goes through 2 points, which seems to be the most difficult problem they could ask you. But remember, we know the procedure for stat calc lin reg, which makes the most difficult problem into the easiest problem, right? So what we can do is we can use the same procedure we used to find the gradient between 2 points to actually find the equation of a line. So we could just put -1, -1 into the calculator. And the only tricky thing is you have to put the points across and not going down. So -1, -1 and 2, -3. You just put those two oops, I didn't do it right. 2, -3. And remember, always use the negative sign down here. Okay? And then now we just do stat calc lin reg. Stat calc lin reg. And sometimes when you do stat calc lin reg last semester, we turned on diagnostics, stat diagnostics, so that we could see the R value. We don't care about the R value here because we're just looking at AX plus B. We're not looking at R, right? So you can see that X list is L1 and Y list is L2. Frequency list must always be blank for this case, okay? Then you just go down to calculate. And the A value is -0.666667, and the B value is -1.66667. Which one is the slope and which one is the y-intercept? The slope is the one multiplied times x, so it would be -0.667. Okay, so for B, I'm going to put the equation of the line. It's going to be y equals -0.667x minus 1.67. And I kept 3 significant figures in each case. If you don't know what 3 significant figures is yet, just go ahead and put some extra digits to make sure that you put at least 3 significant figures. Okay, so that is the answer for C. Number 2, determine the x and y intercepts of the following lines. Okay, so let's do this. Let's graph these, because in math applications class, you can always have the calculator in the test. If they ever just give you any kind of function, the first thing you do, even before you read the rest of the problem, go ahead and graph it, because probably the graph is going to give you a lot of the answers. Okay, so I mislabeled this here. This should be C, right? Okay, I have graphed y equals 5x. Now I want to find the x and y intercepts of this line. Okay, and so let me give you the procedures to find the x and y intercepts of the lines. Y-intercept we did in the investigation. Basically what we did was we graphed it and then we did trace 0. Okay, now x-intercept, we haven't done that yet, but it's one of the additional methods that we use from second calc. Remember I said we did second calc intercept. We are going to learn almost all the options under second calc, and another one of the options under second calc is called second calc 0, and that is what we use when we're finding the x-axis intercept. Okay, basically it's like, when is the function height 0? Okay, so for part A, I have graphed the function. Now I'm going to use trace 0, enter, to find the y-intercept. And the y-intercept is y equals 0. So the y-intercept is 0. Okay, and then I want to find the x-intercept. Oh, there's one more way easy way to find the y-intercept, which is you do second table, and you just look at the first position. And the y value in the first position is 0. You see, when x equals 0, y equals 0. So that's another way of seeing that the y-intercept is 0. Okay? Now we're going to find the x-intercept. So the x-intercept's a little bit more difficult. To do the x-intercept, we do second calc, and then we go down to 0, which is the second position, and then we give it like, basically what we're looking for is, when does the line cross the x-axis, right? So take the cursor, move it a little bit to the left of where it crosses the x-axis, press enter, and then it asks for the right bound, move it a little bit to the right of where it crosses the x-axis, you press enter, and then it asks for a guess. It only crosses the x-axis one time between those two, so the guess doesn't really matter, so you just press enter again, and it tells you that the place where it crosses it, the x-axis, is x equals 0. So it's 0. And this is a little bit confusing problem, because notice that like it's always giving 0 for both x and y, and so it's kind of hard to tell. Well, it's like, which one do I look at? Well, it doesn't really matter. They're both the same, right? But let's say it tells you that the x-axis intercept is 3, 0. Well, the number you're going to look at is the non-zero number. So let's look at a different problem, because I think it's a little bit easier to understand what an x-intercept and y-intercept is when you don't have both numbers being 0. Okay, so y equals 5x is kind of a trivial example because it crosses the origin. The place where it crosses the x-axis is 0. The place where it crosses the y-axis is 0 because it crosses at the origin, right? Okay, let's plug in a different equation. Okay, I'm going to clear the old equation out, and I'm going to put negative 0.4x plus 3 in there. Negative 0.4x plus 3. And I'm going to graph it. And then sometimes you can actually tell from the graph where the y-intercept is. It looks like the y-intercept would be 3. But to make sure, I'm just going to do trace 0, enter. And yes, the y-intercept is 3. Okay, now I'm going to find the x-intercept. Oh, the other way, remember, is you do second table. And if you look in the first position, the y value is 3, so that's the y-intercept. Okay, now we're going to find, and let me show you something about why the x-intercept is a little bit more tricky. The x-intercept is when the y value is 0. Okay, so if I look in the y column of the table, do I see where y equals 0? No, I don't. I can kind of see where it might be close. It looks like it's between 7 and 8, but it doesn't give me the value. Okay, so that's why the best way to do it is to do second calc 0. And I can see that it crosses around there, so the left bound needs to be somewhere to the left of this crossing point. So I press enter because it's already to the left, and then I use my cursor to move it to the right of the point, and it seems like it's going to take me forever if I press this button. So I'm just going to move it to the right. It looks like if I put 10, that it would be to the right. So I'm going to type 10, enter, and then it's on the right side. And then the guess, remember, there's only one crossing point, so it doesn't really matter what you put for the guess. So I just hit enter again. And so the 0 value is 7.5, comma 0. Okay, so or when the value of x when y equals 0 is 7.5, which is the definition of the x-intercept, right? So it's going to be 7.5 for this problem. Okay, let's go back to look at the table again. Remember how I said you can kind of tell the table, it looks like it's going to be 0 between 7 and 8, and it was between 7 and 8. It was 7.5, right? Okay. Let's go back. Let's now put the equation for C in there. So we're going to put negative 0.2 x plus, oh, it is not in gradient intercept form. And when we type an equation into the calculator, we need it to be in gradient intercept form. So the first thing we're going to have to do in this case is we're going to have to arrange it so that y equals is on the left so that it is in gradient intercept form. So we're going to have to do a little bit of algebra. So y is already on the left, but negative 0.2x needs to be moved over. So I'm going to add plus 0.2x to both sides, and that gives me y equals 0.2x plus 1. Okay? And now I'm going to put that in here. So it's not negative 0.2x, it's 0.2x plus 1. And then I'm going to graph that. And the y-intercept looks like it's going through 1. And if you're really clever about it, remember gradient intercept form, the y-intercept value is already displayed prominently in the equation. So you can already see from the equation. But you can always do it with trace 0. So let's do trace 0. And the y-intercept is 1. So yeah, y-intercept is 1, just like the equation shows us. And the x-intercept value, it looks like it's around here on the left. Let's do second calc 0. And even if you can do this using other algebraic methods, the point here of repeating this, which a lot of people already know how to do, is to show you how to do it on the calculator, because once you start using curves, you're not going to be able to do it using the same methods. Sometimes algebraically, you're not going to be able to do it. So that's why we're learning how to do this method. And so I move the cursor over so that it's to the left of the intersection point, and I press enter. And then I move it a little bit to the right of the intersection point. Remember, you can just type in a number. If you could say, oh, I think x equals negative 1 would be to the right. So I'm just going to put x equals negative 1. I hit enter. And there's my interval. It crosses somewhere in between there. It only crosses at one point, so the guess doesn't matter what it is. So I just hit enter. If it crosses in two places, then you might need to be careful about your guess. But in our function, it only crosses in one place, so you don't have to be careful. And the x value is negative 5, right? So the x-intercept value is negative 5. Okay, and that's it for this page.